Hey, this is extension 3.2, factoring. Our goals for today: 1. Find the greatest common factor of two numbers. 2. Find the GCF of a number and a variable term. And 3. Factor an algebraic expression. A lot of what we're going to talk about today is review. Let's start with a reminder of what a factor is. A factor is a number or quantity that when multiplied with another produces a given number or expression. So for example, the factors of 10 are 1, 2, 5, and 10. This is true because 1 times 10 is 10 and 2 times 5 is 10. The factors of 32 are 1, 2, 4, 8, 16, and 32. This is true because 1 times 32 equals 32, 2 times 16 equals 32, and 4 times 8 equals 32. So variables can be factored too. For example, 2n is the variable term. Well, the factors of 2n are 1, 2, n, and 2n. This is true because 1 times 2n equals 2n, and 2 times n also equals 2n. The factors of 8x are 1, 2, 4, 8, x, 2x, 4x, and 8x. This is true because 1 times 8x equals 8x, 2 times 4x equals 8x, 4 times 2x equals 8x, and 8 times x equals 8x. If you have trouble identifying factors of a given number, you can use the T-chart method to find them. Always start with 1 and the number itself and go up from there. For example, the factors of 16 are 1 and 16, 2 and 8, 4 and 4. Let me show you another example. Let's say we want to factor 24. So you create a T-chart. You always start with the number and itself. So 1 and 24, and then you go up from the 1. So you think about 2. Well, 2 times 12. You can do 3 times 8. What about 4? Well, I can do 4 times 6. 5 will not go in, and then I'm going to get right back to 6, so I'm done. Quick reminder about greatest common factor. That's the largest factor in two numbers lists. There are two methods to find the GCF. Method number 1, you can list all the factors and identify the greatest number in both lists, or you can use the prime factorization method. Let's review method 1. So let's find the GCF of 12 and 34. So the first step is to list all the factors. So the factors of 12 are 1, 2, 3, 4, 6, and 12. The factors of 34 are 1, 2, 17, and 34. The only common number in both lists is a 2. So the GCF of 12 and 34 equals 2. Let's look at 16 and 76. The factors of 16 are 1, 2, 4, 8, and 16. The factors of 76 are 1, 2, 4, 19, 38, and 76. Now they share a 2 and a 4, but the GCF is going to be the largest common factor. So therefore the GCF would be 4. We never use 1 as a common factor. Another method is prime factorization. So let's look at it with finding the GCF of 12 and 34. So we start with 12, and what you do is you make a tree diagram, and every time you get to a prime number you circle it. So if I start with 2 and 6, 2 is prime, so I circle it. I can break 6 down into a 2 and 3. Both 2 and 3 are prime, so I circle those. So the prime factorization of 12 is 2 times 2 times 3. You multiply all the prime numbers. When I factor 34, I get a 2 and a 17. 2 and 17 are both prime, so I'm done. Then you look at both lists. If there is only one common pair, that number is the GCF. Let's look at what happens when you have more than one common pair. Here's the prime factorization of 16. I get 2 times 2 times 2 times 2. Prime factorization of 76 gives me 2 times 2 times 19. I have two pairs of 2's, so I have to bring those down, and I multiply them, which gives me the GCF of 4. Now I know I went quickly through that because this is not really a lesson about how to find the factors of a number or how to find GCF. Those are all things we've done in the past. What's new is how to factor an expression. So these are the steps we're going to follow to factor an expression. 1, we want to find the greatest common factor of all of the numbers and the coefficients in the expression. Remember, coefficients are the numbers before a variable. So like 3n, the 3 is the coefficient. Next, step 2, we're going to divide each term by the GCF. Then step 3, the GCF goes outside the parentheses and the quotients from step 2 stay inside the parentheses. So for example, let's say we want to factor 25 plus 30. Now I know we can add those, but we are going to work through the factoring so that we know how to do it when we hit a variable. So the GCF of 25 and 30 is 5. So what you do is you divide all of the terms inside the parentheses by the GCF. Well, 25 divided by 5 is 5, and 30 divided by 5 is 6. So this expression is going to become 5 plus 6. Then you take that GCF, and that goes outside the parentheses. Remember what this means. This means I have 5 groups of 5 plus 6. And if I listed all of those out, that would give me 25 plus 30. Let's look at another example. Here I'm factoring 12 minus 18. So again, the steps are 1, find the GCF. The GCF is 6. So I take that 12 minus 18 and I divide all of the factors, change that back, all the factors inside the parentheses by the GCF. So I'm going to divide by 6, divide by 6. 12 divided by 6 is 2. 18 divided by 6 is 3. So that becomes a 2 minus 3, and the GCF also goes outside the parentheses. What this means is I have 6 groups of 2 minus 3. Now let's factor an algebraic expression. So these are the steps we're going to follow. They're the exact same as before. Step 1, we're going to find the GCF of the numbers and coefficients. Remember, coefficients are the numbers in front of the variables. So in like 5x, 5 right here is the coefficient. Then we divide each term by the GCF. The GCF goes outside the parentheses, and the quotients from the division in step 2, they stay inside the parentheses. So let's factor 25 plus 30x. So I want to find the GCF of my two of the numbers. So of the 25 and the coefficient 30. The GCF is 5. So I'm going to divide by 5, divide by 5. Well, 25 divided by 5, that's a 5. 30 divided by 5 is a 6. So 30x divided by 5 is 6x. Then that GCF goes outside the parentheses. So again, what this means is I have 5 groups of 5 plus 6x. Here's another example. Let's factor 20 plus 8x. My GCF of 20 and 8 is 4. So every term inside the parentheses gets divided by 4. Well, 20 divided by 4 is 5. 8x divided by 4 is 2x. And the GCF goes outside the parentheses. What this means is I have 4 groups of 5 plus 2x. Okay, let's do number 1. I have a 9 plus 21. So you want to think about what's the GCF of 9 and 21. The GCF is going to be 3. So what you're going to do is divide all the terms inside the parentheses by the GCF. Well, 9 divided by 3 is 3, and 21 divided by 3 is 7. Then the GCF goes outside the parentheses. You can always check to see if you're right by doing the distributive property. Because really what we're doing here by factoring is we're actually doing the distributive property in reverse. So let's check it. So let's distribute that 3 to the numbers inside the parentheses. Well, 3 times 3 is 9, and 3 times 7 is 21. Checks out. Next, let's try 36a plus 16b. Well, the GCF of 36 and 16 is 4. So I'm going to divide 36a by 4 and 16b by 4. Well, 36 divided by 4 is 9, so 36a divided by 4 is going to be 9a. 16 divided by 4 is 4, so 16b divided by 4 is a 4b. And then the GCF goes outside the parentheses. So I have 4 groups of 9a plus 4b. And again, I can check it by doing the distributive property. Well, what's 4 times 9a? It's going to be a 36a. What's 4 times 4b? It's going to be a 16b. Checks out.